In Module 2, Lesson 11, we're going to develop rules for multiplying signed numbers. So we're going to be extending our whole number multiplication to the integers. We'll complete quadrants 1 and 4, 1 and 4 of the table to show how sets of matching integers will affect a player's score in the integer game. For example, 3 2s would increase a player's score by 2 plus 2 plus 2, or 6 points. So if we had 1 1, it would increase the score by 1. If we had 2 1s, it would increase by 2. 3 1s would increase by 3. 4 1s would increase by 4. 5 1s would increase by 5. And we'll continue on filling quadrant 1 in the same manner. 2 1s, 2 2s, 3 2s, 4 2s, and 5 2s. So quadrant 1 represents picking up positive cards. Give me the... Okay. In quadrant 4, we'll look at picking up negative cards. So if we pick up 1, -1, the value would be -1. 2 -1s would be -2. And we'll complete the rest of the table in the same way. And as we look at our quadrant 4 completed, we can see that picking up negative value cards will decrease our score. Now in quadrant 2 and 3, we're going to show the effect of removing cards. Because in quadrant 1 and 4, we were adding cards. In quadrant 2 and 3, we're going to remove cards, both of positive value and of negative value, and we'll see what effect that has. So if we remove a positive 1, that would result in a -1 change. If we remove a 2, that would be a -2 change. Removing a 3 would be a -3 change. Removing a 4 would be a -4 change, and removing a 5 would be a -5 change. We'll continue on, keeping in mind that if we remove 2 2s, that will have a -4 change in our score. So we can see that when we remove positive value cards, we are reducing our hand. And then finally, in quadrant 3, we'll fill these values out. Keeping in mind that if we remove a -1, it will increase our score by 1. Likewise, if we remove 2 -1s, that will increase our score by 2. And so we can see that quadrant 3 represents removing negative value cards. What patterns do you see in the right half of the table? You should see that the products in quadrant 1 are positive, and in quadrant 4 are negative. When you look at the absolute values of the products, quadrants 1 and 4 are a reflection of each other with respect to the middle row. +3, -3, +6, -6, +9, -9, and so on. You can see that they are a reflection, their absolute values. Look then So I'll continue to show our table as I ask the questions that follow in your lesson. The products in quadrant 2 are all negative values. If you look at the absolute values of the products, quadrant 1 and 2 are a reflection of each other with respect to the center column. For example, in quadrant 1 we have +1, in quadrant 2 we have -1. And so their absolute values are the same. Looking across that center column, in quadrant 1 we have 2, in quadrant 2 we have -2, 4, -4, 3, -3, 6, -6, and so on. So we can see that quadrant 1 and quadrant 2 are reflections of each other as far as their absolute values go. The relationships or patterns that you should notice between the products in quadrant 2 and the products in quadrant 4 are that the products in both quadrant 2 and 4 are all negative. And each product of integers in quadrant 2 is equal to the product of their opposites in quadrant 4. So for example, 1 times -1 is -1, which is the same in quadrant 4. If we were to skip to 5 times -5 in our far corner, we find that both have -25, and likewise for each of the values. By now, we should have established a certain pattern that we're noticing, so you may be able to make the comparisons between quadrant 1 and quadrant 3 in the same way that we compared quadrant 2 and quadrant 4. So is it possible then to know the sign of a product of two integers just by knowing in which quadrant each integer is located? Of course. It's possible to know the sign of a product of two integers just by knowing the integer's quadrant, because the signs of the values in each of the quadrants are consistent. Two quadrants contain positive values, and two quadrants contain negative values. And so finally, in our exercise, we're going to think of real-world situations that can be modeled by each of the multiplication problems. And we can use the integer game as a resource to kind of help us. Negative 3 times 5 could be that I lost 3 $5 bills. Negative 3 showing a loss, a 3-time loss of $5. In problem B, with negative 6 times negative 3, I could say that I removed 6 negative 3's from my hand in the integer game. And if I removed 6 negative 3's, my score will increase by 18 points. And finally, in exercise C, 4 times negative 7 could be if I lost negative 7, or if I lost 7 pounds every month for 4 months, my weight would change by negative 28 pounds. In summary, to multiply signed numbers, we would multiply the absolute values to get the absolute value of the product, and then the sign of the product is positive if the factors have the same sign, and the sign of the product is negative if they have opposite signs.